Hello, welcome to Introduction to Java Programming. In this session, we will discuss runtime polymorphism in Java. As part of this, we will understand what is upcasting, what is downcasting, what is static polymorphism, etc. Let's begin. So in inheritance, we understand that classes will acquire properties from their parent classes, right? And there is a properties, there is a special property in inheritance, which I have not told before, is something like this. The objects of the subclasses are specialized objects of superclasses. So we understand this inheritance relationship as generalization by specialization, right? The generalized thing is the parent class and the specialized thing is the child class, right? So here there is a property, the special property. The property is this: the objects of subclasses are specialized objects of superclasses. Hence, parents or superclasses can refer to their child objects. So this is the property. Since the child objects are specialized objects of the parent classes, parents can refer to their child object. So this property has to be understood properly. Okay, so in order to understand that, let's say I have a class A where I have certain data members and methods. Now I have class B which extends A. So now class A is my superclass and class B is my subclass. Now this is possible. This is possible actually. So now what I'm doing, I'm creating an object of B. This is my child object, which is being referred by my parent type, which is being referred by my parent type. A is a reference variable which is of type A. A is my parent class. So parents can refer to the child object, right? And this is actually called as upcasting. Okay, so what is upcasting? Upcasting is a process in which parents refer to their child object or using a super type reference variable to refer to the child object or parent reference variable to refer to the child object is actually upcasting. This upcasting is possible because of this particular property. Fine. And since we have upcasting that is possible, so parents can refer to their child object. That means any object, whatever the object that you create can be referred by your object class. Object O equal to new A, new B, new C, new student, new customer, whatever it is, because object class is superclass of all Java classes, right? So your parents can refer. So your parent, it not immediate parent, it can be parent in your chain. Anybody who is a parent in the chain can refer to the child object. That's called upcasting. And downcasting is vice versa. And downcasting is not possible in Java. Okay, so now what happens? This upcasting plus overriding. So we understood overriding, right? So overriding happens with a method actually. Okay. The method signature must be same. A subclass method redefines the behavior of the parent class method. That's what overriding we have understood. So this upcasting plus overriding method always leads to something called runtime polymorphism, RTP, runtime polymorphism. Whenever there is upcasting, parent is referring to the child object, and a overridden method is called, which is actually leading to a runtime polymorphism, and this is also called dynamic method dispatch. This is also called dynamic method dispatch. So in order to understand this concept, before going into the details of this runtime polymorphism, in order to understand this upcasting, let's actually go through our program snippets. Okay, so as usual, we have our class employee written, a class employee with 3 instance members and 1 static member, and there is a constructor that is constructing all the instance members. There is a getter for basic because this was used by some child classes, and there is a disk method that displays all the 4 data members, and there is a cal salary method which is actually calculating the salary of the employee based on certain allowances which are declared locally. Okay, this is my employee class, and this is perfect, and this is working actually. So let me keep this compiled and ready. Yeah, so this is fine. Now there exists a child class. There exists a child class, that is public class tech employee, extends employee. Whenever it extends, we know all these things are possible. Tech employee can get all the non-private members. It can have its own members, and it can redefine the methods of the parent class. The same thing is happening here. So it acquires all the non-private members, and it has its own child specific thing. And since parent class has a constructor, so you need to have a constructor, and we are actually invoking the parent class constructor using the super, and the child specific member is being constructed over here, and this is a constructor. And in the child class, we don't have any specific child specific methods, and just to print the bonus along with employee details, we are overriding the this method. So we are specifying that with @ override, and during the overriding, we are actually making a call to the disk method of the parent class, and bonus is getting printed separately. And the cal salary is also getting overridden because this child has a bonus. So that's why this class is technical employee, because some special properties, some bonus is given to them. So when we process salaries, so salary has to be processed with a bonus as well. So a salary is calculated and we have the bonus over here. Okay, so that's what actually we have seen, and that absolutely works fine. But now you can actually see, we can straight away have the upcasting possible here. So let's observe. I'm saying employee E1 equal to new tech EMP, new tech EMP. So the object I'm going to construct is technical employee. So now how many values I have to pass? I have to pass 4 values. First one is integer. So now this time I am passing 1, 2, 3 as the employee ID, and employee name is actually some ASDF, and employee basic is going to be 1 lakh, and the bonus is, let's say, 10,000 rupees. Okay, so now the object being constructed is actually the child one and referred by employee type. So is it possible? Is it possible, or a compiler will give an error? Okay, it is possible because it's called upcasting. So let me actually compile and show you that this is not going to be an error actually. So java emp.java, it's not going to be an error. It's not going to be an error. So employee E1 equal to new tech employee. So what happened? A child object is being referred by parent. This is called upcasting. Okay. So now by using this E1, I can actually call all the methods, all the overridden methods, or all the methods which are actually defined in the parent type. Okay, because the reference type is of employee. By using this E1, I can actually only call the methods which are defined in this employee, like a get basic can be called, disp can be called, cal salary can be called. Any child specific is there that cannot be called, but I don't have any child specific methods over there. So we can actually call this method. So this method is the overridden method. This method is a overridden method. I can call even.cal salary as well. And this cal salary is also a overridden method. It's also a overridden method. Okay, so now, as I told here, upcasting plus overridden method leads to runtime polymorphism. So here, this call actually makes a runtime polymorphism. This call also makes actually a runtime polymorphism. Okay, so even.disp. So which method will be called actually? See, this technical employee has how many methods? Yeah, this technical employee has methods from the parent and its own overridden methods actually. So that means there are 2 disp methods. One is from the parent and one is the overridden method. And cal salary also, one through inheritance, another is overridden method. So now what we are doing, yeah, so that is something like this. Let me explain here because this needs some explanation. Otherwise, it is tough to understand. Yeah, so let me have this technical employee class here. Overton. Yeah, this is my, let's say, technical employee class. So how many methods are there in the technical employee class? Let's see here. Tech EMP. How many methods are there? So it has this method. Yes, there is a this method of its own. So that means it belongs to its own technical employee, tech EMP. And of course, it has a this method. It has a this method of the parent also. Of the parent also. This is how we represent. And two colons we will actually call as the scope resolution. Of course, it's not there in Java, but it's there actually in C++. Now we have a cal salary method also, right? This cal salary method is also available as part of technical employee and also as part of yeah, so technical cal salary is available in technical employee twice. One is actually its own version, other is the employee version, because through inheritance actually. Now, so e1.disp, e1.disp, we have to call a method actually disp. So this disp method, which disp method will be called? Which disp method will be called? The disp method of the technical employee or the disp method of employee? So here there is an ambiguity. Okay, first, did you understand that technical employee has two disp method and two cal salary methods? One has to understand this, because through inheritance you will get disp and cal salary methods, and in the child we are redefining it. That means we are rewriting it, right? So again, two methods. Fine. Now when e1.disp call is made, which method has to be called? So e1 type is employee, so go and call the employee version, and e1 is referring to technical employee object. That means the object created is of technical employee referred by the parent type, that is e1 actually. Okay, it's not referring to the employee object, it is referring to the technical employee object. So object is of technical employee. Fine. So here there is an ambiguity. E1 is of type employee, so I have to call this employee method, but E1 is referring to technical employee, I have to call this one. So usually what happens, compiler always actually checks for the types, always checks for the types. If the type is matching and the object is also matching, it binds it. So that we call as a compile time binding or static polymorphism or early binding. So compiler, what it will do is, it will actually check the type of the reference variable and where the reference variable is referring to. If both are same, it only binds it. It only binds it. So binding means linking the method call to method code. It binds the particular method code with this particular call. So that is called static polymorphism. So earlier, whatever the programs we did, right, all are static polymorphism only. I am saying student S1 equal to new student. S1 is of type student, referring to student object. Employee E1 equal to new employee. E1 is of type employee and referring to the employee object. Our customer C1 equal to new customer. So all are static polymorphism, because the binding will happen by the compiler only. That's why we call as a compile time binding or early binding, like that. Okay. So, but here compiler was into ambiguity. Compiler was into ambiguity because E1 is of type employee and E1 is referring to technical employee. So which method has to be called? Which of these both methods, whether this one or this one? So it is in ambiguity. So in this scenario, compiler usually reports an error. But there is a rule in Java, right? Parents can refer to their child objects. So by using references also we can call the methods. So that's why compiler was told not to report any error. Rather, compiler was asked to just ignore and leave it for the runtime to take care. So here compiler will not give an error, but it actually leaves it to the JVM. What is runtime? Java Virtual Machine. It actually leaves it for the JVM to do this kind of binding, because it could not able to do that binding because of ambiguity. Types are different, object is different. So now JVM has to take care. So how JVM has to take care? Which method it will actually call? So even the case with cal salary also, even.cal salary. Is it the cal salary of the parent or is the cal salary of the child? Okay. So now when it comes to JVM, JVM solves this problem. Okay, simply by having one rule actually. What it says is, okay, so what a overridden method is called. Okay, so this method and cal salary, these overridden methods are called with the parent reference. It's okay. Now let's find out, leave about the type. Let's find out which object it is referring to. Which object it is referring to. So this E1 is actually referring to the child object. So child object is the technical employee object. So what JVM says is, don't worry about the type. Since the reference type, okay, so since the reference type is something, ignore it, don't worry. But that reference is referring to which object? Is it the parent object or the child object? If it is parent object, call the parent method. If it is child object, call the child's method. So now here, E1.disp, E1 is referring to technical employee, which is actually child object, right? Now call child specific disp method. So this is the child specific disp method. Okay. Now when you say E1.cal salary, now E1 is referring to technical employee. So call child specific cal salary. Okay, so that's what actually is runtime polymorphism. Since compiler cannot able to bind because types are different and reference is referring to some other object, it leaves for the runtime to take care. During the runtime, JVM binds by just seeing which object being referred by the reference variable, not by the type. Okay, and it referring to the child because subcasting, it refers to the child object only. Let's call the child specific version. Okay, so when we actually call this, I should get my child overridden disp method, and cal salary means my overridden cal salary should come actually. So let's verify this. Let's verify this. Okay, so now let me actually compile this. Before that, I'm saving. Now let's see whether child specific is called or something else is called. Java C technical employee.java. Okay, yeah, semicolon is missing. Let me put a semicolon over here. Yeah. So that's a syntactical error. So Java C technical employee.java. It's compiled successfully, right? So now I say Java tech emp. Yeah. Now let's see. Yes, child specific methods were called actually. Let's see now. So when I say disp, which is getting called child specific method because I am printing the bonus also, right? When I say E1.cal salary, what it is printing? So it's printing 1.9. So that means what? Child specific cal salary. 1 lakh plus 80 plus bonus is 10. So here runtime polymorphism happened. Runtime polymorphism happened because a overridden method is called through parent reference. So that time call the child specific version of the method, not the parent type actually. So that's what actually explained over here. So this RTP is called dynamic method dispatch because why we call as dynamic method dispatch. So here dynamic binding is happening. So here dynamic binding. So the binding of method code to the method call is determined at the runtime. This is also called dynamic binding. This is also called late binding, or this is also called runtime binding. So dynamic, or we can say late, or we can say runtime because it happens at the runtime. So during the runtime, what happens? Let's see here. When a overridden method is called through a parent reference, RTP occurs. So during the RTP, during this, JVM resolves the method call based on the object being referred by the supertype. Object being referred by the supertype. So I have employee E1. E1 is supertype. E1 is actual reference variable of supertype employee. So what object is being referred? Is the child or parent? If the child, then call child specific method. If it's a parent, call parents method. So object usually in upcasting being referred to child only. So call the child specific method. So that's what actually happens, and that's what JVM will do during the runtime polymorphism. So not by the type of reference. Don't worry about the type of the reference. Just actually see which object is being referred, call that specific method actually. So since compiler ignores this binding, that's why it is called as dynamic binding actually. So that's why it is called as dynamic binding. So here employee E1 equal to new tech employee, straight away upcasting is happening. And here E1 dot disp and E1 dot cal salary runtime polymorphism is taking place. So let me also tell you something else also here. Yeah, so now I am creating something like this. Employee E equal to new employee. So now what happens here? Is it upcasting? No, there is no upcasting actually. There is no upcasting. It's not upcasting, not upcasting. Because object is of type employee, reference is also of type employee, not upcasting. Right? E dot disp. I am saying E dot disp. Okay. So before that, for clarity, what I do is I will actually print a few things actually here. Yeah. Okay. Employee equal to new employee. E1 dot disp. E dot disp actually. So which method will call? Which method will call? This is a static polymorphism, static binding. Object is of employee type and the reference is also of type employee. So here actually what happens? Static binding. Here actually static binding, right? If it is a overridden method, then it's actually static polymorphism. It's a static polymorphism if it's a overridden method. Okay, now E1 dot cal salary also. E1 dot cal salary. Now which method will be called? Okay, E dot cal salary. E is of employee type, new employee. Okay, so here also there is a static binding, right? Here also static binding. So all here and here parents methods are going to come print parents method only, right? Here it will be parents method. Here also it is parents method. It's very much clear. It's very much clear. Okay. So now I will actually do a PL and I will have these things also get printed. So now this is completely parent thing. E1 E dot disp means you will have just displaying all the values except the bonus. Cal salary is just salary plus 80%. Now what else also can be done, what else also can be done is, what else also can be done? Okay. So now I am creating a technical employee. Technical employee TE equal to new technical employee. New technical employee. Of course. So here when I say a new employee, I have to pass the values. I forgot to pass the values. Let me pass actually 3 to 1. Let's say ABC and basic is let's say 1 lakh. Yeah, basic is 1 lakh because I have a constructor over there. No, I have to construct directly. Now technical T equal to new technical employee. Now here what I'm doing is 1, 2, 3, 4, and this one is actually kind of XYZ, and the basic is same for everybody just to check the salaries, and here I'm passing the bonus as well. Okay, now what happens? So T dot disp. T dot disp. So first of all, let's understand, is it upcasting? No. It's upcasting? No, it's not upcasting. So not upcasting. These also not upcasting. Upcasting means referring with parent things actually. It is also not upcasting. Now T dot disp. So what about this? What about this? TE TE is actually child specific thing and type is tech employee, and disp is a overridden method. So here actually what happens here? It is just a static polymorphism only. Static polymorphism. This is not dynamic polymorphism because there is no abstraction. Sorry, there is no upcasting, right? There is no upcasting. Okay, static polymorphism only here also. Now here TE dot cal salary. Overridden method is called. Overridden method is called. But actually what is happening? Static polymorphism because there is no upcasting. Here also it is static polymorphism. Okay, so this is also fine. So let me actually write one more, and the last thing what I'm writing is so important. Let me sum up what I have did actually. So this first thing, whatever we did, we have understand earlier. So that is actually leading to runtime polymorphism because upcasting is there. So here directly I have created the parent object, static binding is there, and there is no upcasting, right? But here, this is the child, and overridden method is called. So static polymorphism will happen. Static polymorphism, because overridden method is there, so polymorphism will come into the picture. So here also it is static polymorphism. Fine. Now let's actually do something here. So what I'm doing here is I am doing something like this. E equal to TE. This is important to understand. E equal to TE. What is going to happen here? E equal to TE. So now what has happened earlier, and let me actually annotate and tell you, because this is something important to understand. So I have one object created here, and I have another object created here. So first object is 28th line, 28th line actually. So now I have E, which is actually referring to here, this is TE. E, and what is the object that got created? Employee object only. And this is techie employee object. So let me actually write the names also so that you will understand. So this is the employee object, and this is the tech employee objects. The object created is employee over here, the 28th line, and here the object created is line number 32, the technical employee object. Okay, so when I call e dot disp, e dot salary, employee methods will get called. When I say t dot disp and t dot cal salary, here the overridden methods of technical employee are going to get called. So since this is overridden method, we have a static polymorphism here, but here we don't have a static polymorphism because this is not overridden method in employee class, right? But here what I'm doing, E equal to TE. So TE is assigned, TE value is assigned to T value is assigned to E. That means this value is assigned to E. So that means what? E also now referring to what? Technical employee. That means both are actually referring to technical employee, and this got broken because E value got replaced by TE. This got replaced by TE. So this is broken. So this actually becomes a garbage. Now both E and TE are referring to technical employee only. That means E is a parent reference referring to child object. Parent reference is actually referring to child object. So that's actually is going to happen. So what is this? So this is actually upcasting. So we can specify upcasting like this also. Okay, by assigning a reference to other, we can actually have upcasting. Right? Now with the E, I say E dot disp. E dot disp. Now what happens? Disp is a overridden method. Disp is a overridden method because E is referring to TE. Object is child object. So runtime polymorphism will happen. So when I say E dot cal salary, now what's happening? So here also runtime polymorphism will happen because E is now referring to TE. TE actually a technical employee object. So parent reference is referring to the child object. So here runtime polymorphism will happen. Okay, see now E dot disp here and E dot disp here, right? So it behaves differently because it calls a parent's method, because runtime polymorphism it calls here child's method actually, right? It calls the child's method. So here also it calls the child's method. Okay, so this is runtime polymorphism. So same method called on same reference but behaving differently. E dot disp behave differently and E dot disp also be differently. E dot cal salary gives something and this E dot cal salary gives me something actually. Okay, so when you specify upcasting, you can also specify like this, not just directly like this, but also you can actually do like this. So here first and last are runtime polymorphism cases. So here just there is no runtime polymorphism, there is no static polymorphism also, just a static binding will happen. So here static polymorphism will happen, but there is no runtime polymorphism because your object type reference type and object both are same actually. Okay, so this is about runtime polymorphism. Let's observe the outputs for all of them. Java C technical employee compile successfully. There is no issue. I can do that. Now you can actually see here. First one I said runtime polymorphism. So you have salary equal to 1.90 and bonus is also getting printed. The second one is not runtime polymorphism. This is just parent things. So that's why parent has no bonus, that's not getting printed, and only 80% of allowances, there is no bonus. So now coming to the second, so there is static polymorphism because overridden method is called, right? So you have the salary getting printed and bonus is also getting printed. Only thing is here runtime polymorphism is not happening because there is no upcasting. The same thing is over here in the second, but here there is a runtime polymorphism. Binding here happening at runtime. Okay, and second and third cases binding happens statically, but first and the last cases, this first case and last case, the binding is happened runtime. Okay, so when runtime polymers happen, child specific things are going to come. See here, this one and this one actually you can see the same kind of output because 1.90 is getting printed and bonus is also getting printed. So this is about the runtime polymorphism. So hope you understand. So this is a little bit complex concept because you have static polymorphism, you have upcasting, you have static binding, dynamic method dispatch. So many new words are there, but if you follow properly, it's easy actually. And runtime polymorphism is possible because there is upcasting. Upcasting is because the objects of classes are specialized objects of the superclasses. Okay, so hope you have understood and meet you in the next session. Thank you.